This is chapter 26, example 4, and what we have here is another problem where it does a whole bunch of stuff. So essentially the circuit counts the number of times the input A is 2 greater than input. So that means, let's start with this black box diagram, and it has two inputs, A and B. They're 8-bit inputs, and there's a clock in here also. So what it's doing is counts over the output of the circuit is the count. So it's counting how many times A is true greater than B. It's counting the number of times something happens. This necessarily is an event counter. Now the count goes between 0 and 127, which is very nice because that's actually a 7-bit counter, and we'll just call this count. And I think we're ready to do this. It's nice that the count automatically rolls over. We don't really have to do anything about this. So this circuit is, because it has an event counter in it, I know there's a counter in this. I mean, it's counting certain events, so we can draw that counter. And this counter is actually going to be the output of the circuit. Interesting thing about this circuit is the next thing to ask yourself does it need a state machine? I'm still not sure yet. I'm going to keep grinding through this and see if I need one or not. Now this one, problems like this, it's not always clear whether you need a state machine or not. Certainly I could use one in here, but if I can get away without using one, I always opt to not put a state machine in this counter. This is it's synchronous. There's my clock. It has an up input. This up input is going to come from somewhere, and we'll worry about that in a minute. So the next thing we gotta do here is we see that it's comparing two things. So we need a comparator. It's wondering if they're equal. Okay, so there's an equal. If the input A is 2 greater than input B, so essentially what we need to do, we're comparing B directly, but what we need to do is take a ripple carry adder, add 2 to A. And so this is an 8-bit, we'll just say 0x02. This is what it's comparing. This is an 8-bit value. We're not going to worry about overflow in this problem. The problem didn't say anything about it. We'll just assume everything is okay. If the problem cared about it, it would have said so. So at this point, we're looking good here. The issue is it's going to add 2 to A and compare it to B. And if they're equal, I'm going to count that. And so what I think I can do here, essentially, attach the EQ output of the comparator to the up control input of the counter. So anytime those are equal and a clock edge comes around, it increments. And at this point, I think I'm done with this problem. The counter is going to overflow automatically. It's going to roll over automatically. I don't need a state machine in this one, but I need to say how this is controlled. And this is internal. It's internal control. So there's a control input. It's controlled by an internal signal, which is the EQ signal. So other thing I need to put here, we need to say up. Hold, and at that point we are going to call this problem done. Let's do a final check on this thing, make sure everything is labeled properly, and we'll call this done.